Hi everyone, welcome to my channel Design with SolidWorks. Continuing with CSWA practice problems, today we'll work on question 4.4. Let's take a look at this question. So in this question, unit of measurement is millimeter gram second. Like always, we need to ensure we're using the same unit of measurement in SolidWorks setting. Now looking at this geometry, we have different views. We have the 3D model, we have the top view, front view, and the right view. My preference is to start with the right view. I'm going to make a 2D sketch from the right view. And then after that, I'm going to use extruded boss feature to make it like a 3D model. Next, I'm going to focus on the two cutout. You can see the right cutout and the left cutout here on the front view. And finally, I'm going to make the 3 holes on the top surface. So with this introduction, let's jump into SolidWorks and start modeling this part. In SolidWorks, first thing first, we need to check unit of measurement, and you can see that we have millimeter gram second, which is a correct unit of measurement. Next, I'm going to click on the sketch and I'm going to choose right plane. Here, I just need a rough 2D sketch. So let's draw that as sketch. Click on line command, and then here, I'm going to make the sketch. So this is a sketch, something like this. Okay. So this is a rough sketch that I want to have. Now let's add some dimensions. I want to start with this feature, the small feature. So click on the smart dimension. This length should be 2 millimeter. This height should be 1.5. I know that this right point and the left point, these two should be on the same horizontal line. So I'm going to choose horizontal relationship. And finally, I need this line, left line, and the right line to be equal. So click on equal, and that's it. Next, I'm going to add the angle between these two lines. Click on the left one, click on the right one, and this angle should be 100 degree. If you look at the geometry, you can see that there's a 40-degree angle, but you don't need to add that. If you have 100 degree here, this angle will be automatically 40 degree. If you try to add it, it's kind of over-define the geometry, and let me show you that. I click on the line, and you see, as you can see, the angle is 40 degree. Now, if I try to add it, it says you're over defining the geometry. You don't need that. So cancel this. We don't need it. Okay. Awesome. Okay, let's add more dimensions to this geometry. Click on the smart dimension. This distance should be 6 millimeter. Okay. Let's move everything to right to make it better. Okay, the angle between this line and this line should be 60 degree. Distance from the left side to right side should be 48 millimeter. Distance between this line and a bottom line should be 10.67. This is quite odd number. I don't know why they chose 10.67, but let's put that for now. Again, the geometry is kind of changing, so what I can do, I can move it like this. So this is 10.67. Let's add more dimension. The overall height of the geometry, if you look at the front view, you can see that it should be 32 millimeters. So from this line to the bottom line, this should be 32. The distance between this line and the top surface should be 7 millimeter. Okay. The length of the top line, this should be 18. What else do we need? And we also know that the distance between this line and the right line should be 28.80. And finally, if you look at the front view, you can see the height of this line. The height of this line should be 8 millimeter. And now you can see the geometry is fully defined. Okay. Now, this is time to add chamfer and fillet. Let's start with the fillet. Click on fillet command, and the radius that we need should be 1.5 millimeter. Click on this corner, click on this corner, this one, and this one. Click on OK, and that's it. Next, we need a chamfer. And the size of the chamfer is 1.5 with 45-degree angle. So I click on sketch chamfer, and I'm going to change this one to 1.5, and I'm going to choose this point, and you can see the chamfer. Okay, Awesome. So now we have everything ready. This is a fully defined geometry from the right view. All we need to do right now is to use extruded bus feature. So click on feature. First of all, click on OK, click on feature, and click on extruded bus. And then here, because this is a symmetric geometry, I'm going to change this one to midplane. And looking at the front view, we know that the overall length is 78 millimeters. So change it to 78, and that's it. Awesome. So now this is the result of the extrusion. Okay. One of the feedback I received from one person on the YouTube channel was that maybe it's good to show the volume for every step for the complex geometry. So let me quickly click on evaluate, show mass properties, and you can check the volume here, 71,092 cubic millimeters. This is the total volume up to this step. Okay, next step is adding cutouts. So to do this, click on a sketch, and I'm going to choose this front plane. And here, click on line command, and again, make a rough sketch. So this is a sketch that I want to have. Looking at the front view, you can add dimensions to this sketch. Click on the smart dimension, and the angle between these two should be 24. The distance between this point and this point should be 8 millimeters. And finally, the height of this line should be 10.67. Again, that odd number, 10.67. But for now, let's keep it. Okay, so I have a fully defined geometry. Click on feature, click on extruded cut, and now you can see this cutout. Click on OK, and that's it. We need this feature on the other side, so it's best to use mirror command. From feature, click on mirror, and then here I'm going to choose right plane as a mirror face. Click on feature to mirror and choose cutout. Click on OK, and that's it. So now I have the feature made on both sides. Last step is to make 3 holes on the top surface. Click on the sketch, click on the sketch command, and choose top surface. Here, there's no hint in the question about the location of the holes with respect to y-axis. But again, it doesn't matter, because at the end of the day, you want to make a hole and you want to find the total volume. So as long as you have the size of the hole perfectly, then you're not having any issue. So for now, I assume that basically the hole is kind of in line with the center point here. So let me add a center point, and let me add a center line basically. So I want the holes to be placed on this line. Now I need 3 circles. The first one is here, this is the second one, and this is the third one. The diameter of the holes, according to question, is 8 millimeters. So this is 8, it's got to be 8, and this is 8. Also, the distance between the left one and this point is 12 millimeters. So this is 12, and this is also 12. Now we have 3 circles fully defined. Click on feature, click on extruded cut, and then here the depth should be 10 millimeters. So let's choose 10, and that's it. Awesome. So now we have these 3 holes. Last step is adding chamfer. To do this, click on fillet drop-down menu and choose chamfer. The dimension is 1.5 millimeter at 45 degrees, and I'm going to choose this one, this one, this one, and click on OK, and that's it. Awesome. So now you can see this is the final geometry. We have every single details modeled here. It's time to check the total volume and make sure this is actually correct. So let's go back to the question and check the total volume. In the question, you can see the total volume. The total volume is 66,273 cubic millimeters. Let's go back to the model and check the total volume for our model. In order to check the total volume here, you can click on evaluate, you can click on mass properties, and here you can see the total volume. The total volume that you see here is 66,264 cubic millimeters. There's really small difference between the number that we found and the number in the question. As a matter of fact, that difference is only 9 cubic millimeters in 66,000 cubic millimeters, which means that in the exam, you won't have any issue, because in the exam, you can simply, the answer that we have is within 1% error margin, and you can simply find the correct answer between all the 4 options or 5 options you have. So this is not a huge deal, but still, I'm really personally curious why this is happening. 9 cubic millimeters difference. And to answer this question, I did some research online, and I want to share something with you. Everything, in my opinion, goes back to the odd number 10.67 that we discussed during modeling. So what I've done, I did some research and I found exactly the same question, but from a different resource. Again, it's from SolidWorks, but from a different resource. Let me share that question with you. So this is a picture of the question, and you can see basically the question is exactly the same. You can see all the dimensions, 100 degree, 2 millimeter, 1.5, section view, all these details. Unfortunately, this question is also incomplete. So the variables that you see here, like C, A, and B, we don't have those variables. So this is, again, not a great resource. However, we can find something by kind of reverse engineering the question. If you look at this question, you can see that we have variable B divided by 3. This dimension in our question was 10.67. So we need a number that is dividing by 3 result in 10.67. Let's find out that number. Basically 10.67 times 3, 32.01. So I'm 100% sure that the variable B is actually 32. If you divide 32 by 4, you're going to get 8 millimeter, which was exactly the same number that we had in our question. So variable B is 32. Now, if I divide 32 by 3, you can see that the number would be 10.6666. It's not 10.67. The number that we have in our question is a rounded version of the actual number. And that could simply result in a difference between our answer and the answer that we have in the question. So let's go back to our model, and instead of every 10.67 millimeter, let's put 32 divided by 3. And then we can check the total volume. Let me close this. So basically in the model, let's click on boss extrude number 1, right click and choose edit sketch. Here you can see every dimension is kind of normal. The only dimension is this one, 10.67. I double click on it and I'm gonna have 32 divided by 3. Click on OK. Still, SolidWorks shows you this as 10.67, but in reality it's 10.6666. So now I have this number fixed. Let's click on rebuild. Now go to cut extrude number 1, click on edit sketch, and I have the same number here. So this is gonna be 32 divided by 3. Click on OK, and that's it, rebuild, and that's pretty much it. I don't think we have any other 10.67 number. Okay, so now we fixed the issue. Let's check the total volume. Click on evaluate, click on mass properties, and here you can see the new total volume. The total volume is 66,272 cubic millimeters. This is exactly same as the answer you can find in a question. So we found a reason. The reason was rounding up a number in a questionnaire that we have. Again, trust yourself. First of all, in the exam, even if you get an answer within 1% error margin, that should be fine. You can find the correct answer between all the options in a question. However, in this case, because I was kind of curious why this is happening, I did my research, and I found that, okay, this could be the root cause of the issue. Simply rounding up a number can result in this difference. And I'm happy that I found the reason, I shared it with you. I hope you guys enjoyed this video. If you have any comments or feedback, please leave comments down below. Thanks again for watching. My name is Ruzbe. Hope to see you again soon in the next videos.